Hello. Today we're going to continue with our modeling with polynomials. And what we need to understand is the connection between the model, the points we're giving, and potentially coming up with the equation, because ultimately the equation is what is useful in mathematics to make extended mathematical statements. And so right now what we're going to look at is just some graphs to prepare us on how to create an equation from a graph. And so if I'm looking at this, it says, given the graph, determine the potential equation in factored form. And they provide us with the f of x, a, and then the two factors. And this is considered factor form. It's different than standard form, so I'm just going to remind you what standard form is. Which is y, which is also considered f of x, a x squared plus bx plus c. And in truth, the a in standard form is actually the same as the a in factored form. Okay? And so you're wondering probably, how did I know that this was going to be a quadratic? And there are a few characteristics of the graph, one being the symmetry involved. I know that it's going to be an even function because of the end behavior going in the same direction. I know the lead coefficient is going to be negative because it's pointing down. All these little clues are really helpful in being able to put pieces together to come up with the equation. And so what we're going to do is kind of go through what it takes to come up with the equation. I'll go through a couple more examples where a little less information is given and see what we can do. And so the first thing I would want to make sure we understand is the relationship between the x-intercepts and the factors. Okay, because these are factors. And what I see as the x-intercepts is x equals -2 and x equals 3. And I can go back to the graph and look directly at where the x-intercepts are, or the zeros. So another name would be 0. And the question is, what factor brought us to the answer of x equals -2? And so one of the factors must have been x plus 2. The other factor would be x minus 3. And so at the moment, if I just make one further connection back to the original equation, it's f of x equals, now I don't know the value of a, but I do know the two factors now, and so I can write them out, x plus 2 and x minus 3. And so from here, you're probably wondering, what do I do next? How does this ultimately help me get the equation? And so what we need is a third point. And so this is really, really important. If I want to make sure that I have a quadratic equation, I need 3 points to define it. 2 points alone can be used to create tons and tons and tons of different quadratics. But once I have that third point, I can actually come up with a direct equation. And what I notice is that the point is the y-intercept is 0, 3. And in fact, that allows us to solve this, but there are other points I might be able to use, and in my other examples, I'll go through and I'll show you what happens when you use something other than a y-intercept. But let's just start here. And so what that means is that x equals 0 with y equaling 3, or if we keep this notation, f of 0 equals 3. And we do need to get used to that notation as we further ourselves this year. And we want to be able to go interchangeably between the f of x form and the y form. And so finally what I would do is I would substitute it. So I start off with f of x equals a, x plus 2, x minus 3. And then I can put in each of the values. So I know that f of x is going to be equal to 3 when x is equal to 0. And so I'm just going to put in this template for the moment, and then I'll put the zeros in. And so 3 is equal to a times 2 times negative 3. 3 is equal to a times negative 6. If I divide both sides by negative 6, I'll get 3 over negative 6 equals a, or in other words, a equals negative 1/2. And so this is supported by the graph that we see, one, because it goes downward. So that leads me to understand the lead coefficient was negative, is what we found. And a half just kind of widens the graph, it shrinks things down vertically. So my final equation would be f of x equals 1/2 negative x plus 2 x minus 3. So then we can look at the question, what if I'm not given the form of the function like above? What are the clues of the graph? So we can go back through these clues. Again, you look at the symmetry of the graph, the fact that its point then behavior points down leads me to understand that there's an even function. So things you can look at are x-intercepts, the end behavior, indicates things about the degree. We talked about the relationship between the relative extrema and the information it provides about the degree. And so what I mean by relative extrema are relative minimum and relative maximum. You can even use the y-intercept to help you later. And you can pick up coordinate points, because the coordinate points really give you information about the association of x's and y's. And so as I'm looking at this, I'll notice that I have roots at, or zeros at, x equals 2, x equals negative 3. I see a y-intercept at 0, 3. I see another point over here at negative 1, comma 3. You can see another point here at 1, 2. And any of these would be useful. And so I'm going to go through and show you what it looks like with the y-intercept, and I'm also going to show you how the agreement occurs, the same answer occurs when I use a coordinate point other than the y-intercept. And so we'll go back. From the information I've gathered, I've got end behavior going down, same direction, so it's got to be even. I see 2 roots, generally implying that we have a quadratic. And so my assumption, at least what I'm going to try out initially, is going to be a quadratic. And so putting those zeros into factor form, I think that this is going to be x minus 2. This is going to be a factor of x plus 3. And ultimately what we need to do is find a to complete the equation. So x plus 3, x minus 2. And I'm going to look at point 0, 3. So I'm going to look at the y-intercept first. So if I make those substitutions, this is my x value, this is my y value, or really f of x. And so I'll see that this is 3 equals a times the x value 0, 0 plus 3, 0 minus 2, 3 equals a, 3 times negative 2, which is negative 6, so 3 equals a times negative 6. Divide both sides by negative 6. And you'll get a is equal to negative 1/2. So I'm going to just circle that. What I want to compare that to is what happens if I work with a point that's not the y-intercept. So I'll pick the point 1, 2. And what does that tell me? That x equals 1 when y equals 2. So 2 equals the a times 1 plus 3 and 1 minus 2. 2 equals a times 4 times negative 1. So 2 equals a times negative 4. Divide both sides by negative 4. You'll get 2 divided by negative 4 equals a. And negative 1/2 equals a. So hopefully you can see it doesn't matter what point I use in truth. And then my final equation would be f of x equals negative 1/2 x plus 3 x minus 2. Okay, so summarize what you've seen here. Make connections between the look of the graph, the degree, the number of relative extrema. There's only one. I know I have to be at least one less than the degree with my relative extrema, how I use the y-intercept, or even coordinate points. I'll give you one more example to look at. And so what we have here is given the graph. And as I look at the graph, I see two relative extrema. I see three roots. I see it going in opposite directions with its end behavior. So my guess is that this function is going to be cubic. Okay. I do need this, and I have to pay attention to the scale, but this is a quarter each time, so this is 75 hundredths for a y value, so the coordinate point is 0, 75 hundredths. The zeros, x negative 3, x equals negative 1, x equals positive 1, and their associated factors would be x plus 3, x plus 1, and x minus 1. Okay, how does that help me? Well, it helps me set up this factored form. So I'm going to use g of x equals the a, that's the lead coefficient that I'm trying to determine, x plus 3, x plus 1, x minus 1. I know that the point I'm working with is 0 and 75 hundredths. And so the rest is going to be very similar. I'm going to put in 0 for each of the x's. I'm going to put in for g of x the 75 hundredths. And let's begin. So 75 hundredths equals a, which I'm trying to determine, x plus 3, so it's 0 plus 3, 0 plus 1, and 0 minus 1. Simplify. A times 3 times 1 times negative 1, 75 hundredths equals a times negative 3. At this point, you can divide 75 hundredths by 3. You could also think about turning this into a fraction of 3/4. I'm going to show you how that's done because that's probably the least likely way that you'll do this. But what I'll do is I'm going to divide by negative 3 and divide this by negative 3. Now we have rules about fractions, but essentially this is like saying 3 divided by negative 3 times 4, which 3 divided by 3 is just a 1. And so this answer is actually negative 1/4. And I didn't need a calculator. I guess the point of this is that my need for a calculator is not there. And so my formula becomes g of x equals negative 1/4 times x plus 3, x plus 1, and x minus 1. And again, you might be wondering why we're doing this. This becomes really important as we begin to look at models and the formulas that